So what they're saying is that if you have this graph and you look between the intervals 0 and 1, at some point that graph is going to cross the x-axis, or y will equal 0. And we just have to use the intermediate value theorem to show that that's the case. Okay. Now we know x is continuous because no matter what value of x you plug in between 0 and 1, it exists. There's no zero denominators, no negative square roots, none of that. So we know it's continuous. It's continuous I should say in the interval 0, 1. Okay. We really just have to find our f of 0 and our f of 1. Okay, so you just plug in both of those endpoints. So if you see f of 0 is equal to 0 to the third plus 2 times 0 minus 1, yep. So f of 0 is just negative 1. And f of 1 is just 1 to the third plus 2 times 1 minus 1, which is equal to 2. Okay, so we know that our f of 0 is equal to 1, which is negative. And our f of 1 is equal to 2, which is positive. So that means if one side of the graph is negative and one side or one point on the graph is positive and there are no breaks in it, it's continuous, that means at some point it has to equal 0. Because you have a negative number that a y equals negative 1 and you have a y equals positive 2. So at some point it has to cross that x-axis. So that's yes.
No, keep on.
Oh, so that's our proof that the 0 exists. Now, what this question doesn't ask us to tell you what it is, but it just wants to know that we can show it exists. All right, so you don't have to show what it is.
So that interval
Mm-hmm.
0, 1, that's not like you plug in 0 to equal 1 or anything like that. Right?
Oh no, those are just your x values.
Okay.
Yep. So that's from from x equals 0 to x equals 1. All right. So since f of 0 is negative 1 and f of 1, it was positive 2. Sorry about that. It's positive 2. Then at some point, this continuous function has to cross the x-axis, which is just f of x equals 0. So a 0 does exist. Okay. And you can do, oh, sorry about that. And you can do that with any other values. Let's say if you plugged in between, let's say, 1 and 5. If you plug in 1 and it was, let's say if you plugged in f of 1 and it was 3. If you plugged in 5, it was 12. Then you can prove that at any point, some value between, what did I say, 5 and 12? Yep, 5 and 12. Then there exists a value for 11. There exists a value for 8. This is at some. You can prove that if it goes from 5 to 12, then everything in between there exists. It has to if it's continuous, because at some point it doesn't just go from 5 and then jump up to 11 or to 12. So you can do this for more than just negatives and positives. All right. Any questions on this one? Yes.
When you say in between
Mm-hmm.
f of A and f of B,
Mm-hmm.
you're saying no less than the lower value and no higher than the higher value?
Exactly. You can pick any value on your x-axis. You can pick any value at all in between whatever, let's say, A and B that you want. And then when you pick any of those two, any value in between there, then that will appear on the graph somewhere. So, and that value will appear either above the lowest or below the highest or somewhere in there, but it exists somewhere. All right.
Now, if we got that, just plain devil's advocate,
Mhm.
if we got those numbers in, say it became +3 and +1,
Mm-hmm.
that means zero would not exist, correct?
Not in that interval. Now, it may exist outside of that interval if you go like further out or something, but in between that interval,
Right.
if it exists, then it would have to do some like quick dropping, and it's possible it could exist, but it's some drastic changes up
So
in there.
according to this fact, like, it just, yeah.
It would have to be one of those really complicated looking numbers. One that simple, it doesn't have that many,
Yeah.
quick drops. But if you get a problem that's really, really, really complicated, it's possible it could drop that quick. All right. Any other questions? Yes.
Just to clarify, so this in the end is just telling us whether it's a continuous graph or not, right?
Yep, it's just one of those, well, if you know it's continuous, then we know for a fact that somewhere in between there, it exists.
Okay.
Yeah, that's all it's really saying. Oh, I thought I saw another hand. Go ahead. Nope, no other hand. All right. Okay, so one. Uh-oh, put that in there. Okay, so the reason why it has to be continuous is this example here. Okay, so let's say you have graph there, you have your x, you have your y. Okay, and let's say we're looking at a graph let's say it picks up here between our A and B. Okay, so we know we have our f of A and we have our f of B. Okay, so if we pick some value, actually that should have been probably a little further over, but some value C, then that means that if we pick this value, f of C equals K, there's nothing here. So there's no value C in between A and B that would equal some value K, or every value of K between f of A and f of B. So that's why it would have to be continuous, because if you had a piecewise or a function that wasn't continuous, then every value between f of A and f of B wouldn't have a C value to represent it. Does that make sense? All right. So I will actually, I'll leave that up. I'll actually leave off there for today. Did everyone sign in? I know the sheet should be floating around somewhere. I don't think I have it.